On this video, you will learn about permutations and combinations. In determining the number of ways in which you can arrange a group of objects, you must first know whether the order of arrangement plays a role. For example, the order of arrangement of a person's teeth is important, but the order of selecting a group for a committee is not, because any order results in the same committee. A permutation is a selection of R objects from a group of N objects taking the order of selection into account. Meaning to say, under permutation, order is important. The number of ways in which N objects may be arranged is given by N factorial. The exclamation mark stands for factorial, and the symbol N exclamation mark can be read as N factorial. It means N times N minus 1 times N minus 2 and so on. Thus, 3 factorial is equal to 3 times 2 times 1, which is equal to 6. For example, if we wish to identify vials of a medication by using 4 different symbols, W, X, Y, and Z, how many different ways can the vials be identified? So for the solution, Rn will be equal to 4. So that will be n factorial, which is equal to 4 factorial, which is the same as 4 times 3 times 2 times 1, which is equal to 24. Suppose we want to learn the number of ways of selecting R objects from a set of N objects, and order is important. Here, we could use this equation. So the number of permutations is equal to n factorial divided by the quantity of n minus r factorial, where n is the total items and r is the item or items to be taken. Example: how many ways can a geneticist utilize 5 distinct stocks of fruit flies, Drosophila melanogaster, in 3 different experiments, if each stock can be used only once and the order of their use is important? So for our solution, the total number of items is 5 and the items taken will be 3. Plugging now these values into our formula, so that will be 5 factorial divided by the quantity of 5 minus 3 factorial. 5 factorial is equal to 120, while 5 minus 3 factorial is equal to 2 factorial, which is the same as 2. Evaluating it further, 120 divided by 2 will be equal to 60. So, there are 60 different ways to set up the 3 experiments using the 5 stocks. We also have the so-called distinguishable permutations. The number of distinguishable permutations P of n objects, where P objects are alike, Q objects are alike, R objects are alike, and so on, is given by the formula P is equal to n factorial divided by P factorial, Q factorial, R factorial, and so forth. For example, find the number of permutations of the letters in the word statistics. In the word statistics, there are 10 letters. However, we have to take into consideration that 3 S are alike, 3 T's are alike, and 2 I's are also alike. So, we have 10 factorial divided by 3 factorial times 3 factorial times 2 factorial. So, we divide it with 10 factorial in order to eliminate the duplicates. Evaluating it further, 10 factorial is equal to 3,628,800. Then 3 factorial times 3 factorial times 2 factorial is equal to 72. Getting now the quotient, that will be 50,400 permutations. Now, let us consider the arrangement of objects in a circle, which we call circular permutations. For example, in how many ways can 4 people be seated around a circular table? So our n is equal to 4. Then let us call the 4 people as A, B, C, and D. So we have here the possible arrangement of the 4 peoples. Observe that all arrangement falling on the same column are just the same because the 4 people are supposed to be seated around a circular table. The permutation of n objects arranged on a circle now is given by the formula P is equal to the quantity of n minus 1 factorial. Going back to the problem a while back, so in how many ways can 4 people be seated around a circular table? So let us use the formula. Our n is equal to 4. So that will be 4 minus 1 factorial, which is equal to 3 factorial, which is equal to 6. So, there are 6 ways the 4 people be seated around a circular table. That is all about permutation. Next will be the combination. Sometimes, we may wish to determine the number of arrangement of a group of objects when order is not important. A combination is a selection of a subgroup of distinct objects with order not being important. The equation of obtaining the number of ways of selecting R objects from N objects disregarding order is, so the number of combinations is equal to n factorial divided by r factorial times the quantity n minus r factorial. For example, suppose that 3 patients with snake bites are brought to a physician. To his regret, he discovers that he has only 2 doses of anti-venom. The 3 patients are a pregnant woman, a young child, and an elderly man. Before deciding which 2 to treat, he examines his choices. So, we have our n, which is equal to 3, and the items to be taken will be equal to 2. So, let us plug in those 2 values into our formula. So, we now have 3 factorial divided by 2 factorial times the quantity 3 minus 2 factorial. So, that will give us 6 divided by 2, which is equal to 3. So, the three choices are a pregnant woman and a child. We also have a pregnant woman and an elderly man. And we also have a child and an elderly man. Note that the child and a pregnant woman is also the same as woman and a child. The woman and a man is also the same as the man and the woman. The child and the man is also the same as the man and the child, because the order does not matter. That is about combination. So thank you for watching, and I hope you have learned something.